Among all the special processors, which is many types of different processing units like distortions, stereo processors, vocoders, pitch shifters, emulations of analog gear which do really complex things, I would like to start off with distortion. And the easiest way to explain that is distortion can be linear and nonlinear. So let's say we have a saturator like this, which is supposed to be a linear distortion if we don't drive it too far. But what distortion does, it clips the signal, so it drives the signal above a certain point and introduces a certain wave shaper onto it. So it has a certain transfer curve from the input to the output. So let's hear distortion so you would know what I'm talking about. I'm going to play this beat only, since I've added this distortion, this saturator onto the master track. So I'm going to play some of the drums to hear what that sounds through distortion. You can hear that slight distortion there. We can, of course, make it more drastic. Now, what happens when you get that nonlinear distortion? You get those harmonics in the sound that were not there originally and weren't supposed to be there. So it's not harmonics that are musically pleasing to the sound, much like the distortion you put on your guitar. So distortions put on guitar really change the sound of the guitar. Now you have distortions like that, non-linear ones that really change the sound and introduce harmonic content that wasn't there in the first place. But you also have saturators like this that emulate different kinds of linear distortions that you used to get from, like, let's say, tape machines being overdriven, or tubes in certain gear overdriven, and you get that kind of a pleasing distortion that you add to the sound. Now, another type of distortion we have right here in Ableton is the Overdrive. And we'll talk about more of these different emulations, distortion types that we have from third-party plugins, stuff like that. But for now, the Overdrive is actually going to drive the signal more into a clipping area where it actually passes through a threshold where it's being really crushed down. And it sounds like this. I'm just gonna put this dry wet, all the way wet, and let's see what that sounds like. It's probably going to be really loud. Of course, in this overdrive, we also have this filter. So we can filter the signal that's being overdriven and then mix that signal in with the original. That's just one extra perk of this Overdrive plugin. We also have different types of distortions that sound like distortions, like this Redux, which actually downsamples and bit reduces the signal, deteriorating the actual resolution of your sound. Now, downsampling actually deteriorates the sample rate frequency of your sound, like this. And we also have the bit reduction, which reduces the amplitude resolution of the sound. See, now I know that's loud, but that's just frequency and amplitude resolution reduction. So it's deteriorating the sound, and sometimes this can produce really interesting effects. So that's one form of distortion too, because it does sound distorted. Now, what other special effects do we have? Well, we have stereo processors. A really simple one would be this utility plugin, where we can actually distinguish between the mid and side pieces of signal. I talked about this when introducing you to equalizers, but let's say this plugin can actually divide our signal into mid and side pieces of that signal, which would mean everything that is completely the same on left and right channels. So everything that has the same signal on left and right, like let's say our kick drum, which is completely mono, is going to be our mid piece of the signal. So from all of these drums, everything that is mid is going to be played once I bring it down to zero. So this is only the mid part of the signal, everything that's mono in this signal. So all the sounds exactly the same on left and right channels. Now at 200, it only plays the side piece of this signal. So everything that is exactly not the same on left and right. So you see pieces of the signal are missing, some parts of the hi-hats too, which are actually in the middle, which are actually identical for left and right tracks. But all of the pieces of the sound, like reverbs and everything that's different on the left and right channels, are being played like this. So we can distinguish between those two, and we can make some balance between those two with this parameter. Now let's hear that on the entire song maybe, because it has more elements, so you can see whatever else is mono and what else is stereo here. So at 0, only mono is playing from the entire song. And this is only the stereo pieces of it. You see the bass is missing because bass is mono in my songs, kick drums, many pieces of other sounds that also have a mono and a stereo component to them. We are completely disregarding that mono component and playing only the stereo one by doing this. So I can actually balance between the mid and side and just play one of those. Now this is the original, how the song sounds in its original form. Only mono, only stereo, original. So we have that kind of manipulation on the left and right. So we can divide the signal into mid-side and then just make a balance between those two. Let's say you wanted to make something more stereo than it actually is. You could up the gain on the stereo component and actually balance between the mono and the stereo component of the sound, the mid and side components, and make it more stereo. So make that stereo component more prominent. What we also have amongst many of these special effects are emulations of certain gear, analog gear, like this cabinet emulation. So we can emulate a speaker, a cabinet speaker, like an amplifier for a guitar, and then a microphone recording off of that cabinet, and then getting that signal. So dynamic, condenser, we can choose what kind of a microphone we're going to be using, so that this would produce the same effect as you playing the guitar into an amplifier and then placing a microphone next to the amplifier to record what you're playing. So this gives you that kind of emulation for the sounds. Let's hear what that sounds like. We also have the dry-wet parameter right here, so we can manipulate that. So this is dry without it, and I'm going to introduce it slowly so you can hear what it sounds like with the effect on. We can choose the speaker, what the speaker is. So we get the sound that might be played through that speaker, recorded with a condenser microphone, near or off axis, meaning where the microphone is placed positionally in regards to that speaker playing, and then we can change sound regards to that too. So that's like a special effect, including more than just one processing on the signal. We'll deal with more of these special effects and what they do once we get to that area. Another really important one I would like to show you right here for the beginnings, for the introduction of this, is, let's say, a vocoder, which is very special. So I'm going to place this vocoder on the master track. I think this is doable and feasible. Now, a vocoder is a special effect, but it's a collection of filters, of bandpass filters. So it divides one of these two signals, and we can say this carrier signal is going to be divided into all of these small bands. You see 20 different bands across the entire spectrum response field, from 20 Hertz to 20,000 Hertz. And we can, of course, broaden that signal or bring it in, so to 18 kilohertz, let's say 14.1, and as they had it from 80 something. And I can use one of these, let's say this serum, as a carrier signal. So let's hear what that sounds like. So this is what I'm producing. Now we're not going to be hearing that signal from the synth, but I will send that synth's output into our vocoder. External. We'll take the audio input for the carrier from, let's say, 55 serum right there. Yep, post FX. So what I'm doing now essentially is I'm going to be taking this sound and letting it through in these bands just as my song plays. So let me just single out this drum beat so you can hear what that sounds like. So what I'm actually doing is I'm using the drums to modulate the output, so the amplitude of every single band here of this synthesizer. This is what the synthesizer sounds like. And I can change the notes to make it more clear for you. So let's say change it like this into something, doesn't even have to be harmonious, just so you can see the change happening. Let's say like that. Okay, let's hear that now. So this is what the synth is playing. And now when I use that synth as an actual carrier for this sound in a vocoder, so it's coloring the drums with its own sound. What we are actually doing is we are dividing this sawtooth, this sound of this synthesizer, into 20 frequency bands. And we are also dividing these drums sound into 20 frequency bands. And it's analyzing the amplitude of each one of those bands for the drums. And then it's copying that amplitude to this sawtooth. Now I know it sounds complicated, but we're actually coloring the drums with the synthesizer. So we're using the amplitude of the drums in certain frequency spectrum parts and giving those amplitudes to this synth sound. So many special things we can do with the vocoder, and we'll get into these in depth and what this vocoder can actually do for you. But for now, it's important for you to just know that they exist. There are many really special things we can do by using effects. We also have autotuners and different effects, but we'll get into those when we get into special effects level of this course.